All right, today we're going to be talking about adding probability or probability with or. So let's go ahead, let's get started with some of the vocab. So first off, we have mutually exclusive events. So what this means is a disjoint, so they are events that cannot occur at the same time. So you will see it written as A or B. So what you're going to do is you're going to add the probabilities together. You'll also see it written like this with that, so that means the or. So it still means you're going to add the probabilities together. Now, if it's mutually inclusive events, so inclusive is a keyword, that means they can occur at the same time. So they're mutually inclusive, use these formulas. So you'll have the or here. So here's the big difference, is you're still going to add, just like we did over here, but you have to subtract any overlapping parts or any repeating parts that you have within it. So you can also have it written in this format. So same thing, you're going to add the probabilities for the things you're looking at, and then you're going to take away the part that would be the overlapping or the subtracting or the repeating part of it. So let's first determine whether it's mutually inclusive or exclusive. So rolling a 2 on a 6-sided die and rolling an odd. So they can't happen at the same time because 2 is not odd. That's exclusive. If you're rolling a 4 on the die, that's all even, so that could happen, so it's inclusive. Your birthday falling on a Monday and your birthday falling on the weekend, well, Monday is not on the weekend, so it's exclusive. You can own a car and you can own a house at the same time, and you can have math in spring semester and you could have science in the spring semester, so those are inclusive. All right. So now let's go ahead, let's practice some examples. So for a mutually exclusive, so again, this is where you're writing, and these are things to where it can happen at the same time. Or excuse me, can't happen at the same time. So remember these examples right here, this is what we're looking at here. All right, so in this case, a group of 120 students, there's 30 freshmen, 42 sophomores, 37 juniors, and 11 seniors. Find the probability that a student picked at random is either a junior or a freshman. So again, these are exclusive because you can't be both, so it's one or the other. So what you're going to do is you're looking for juniors, which is right here, and you're looking for freshmen, which is right here, and I color-coded it for you. So you're going to take the probability of juniors over total students, and then you're going to add the probability of freshmen over the total. Now they both have common denominators, and then just go ahead and add the top for that. So this is the probability that it'll be either a junior or a freshman. All right, for mutually inclusive, this means they could potentially happen at the same time. So you're going to take your two probabilities, you're going to add them together, but you're going to subtract or take out the part that is overlapping. All right, so again, keyword or, so we're looking for that. In a group of 101 students, 40 are juniors, 50 are female, and 22 are female juniors. Find the probability that a student picked from this group at random is either a junior or a female. So what we need to do is we need to figure out our juniors out of the total. And then we're going to take the probability of female over total. Now, this is the part where it overlaps or it repeats. So we need to subtract that part so we can take any that are repeating. So here we have female juniors. So this is the part that repeats, and that's why we're taking that out. So then go ahead, they all have common denominators, so you're good there. So just go ahead, add 40 plus 50, which is 90, take away 22, and you'll get 68 over 101 as a probability. All right. So I did these two here just to show you, but for this one, we need to identify first if it's inclusive or exclusive, and then you're going to find the probability. So it says here, if you roll a die, what is the probability that you roll an even or a number less than 3? So what I did is I wrote all the possibilities that you could roll. And then we're looking for even. So here's your even numbers. So we got 3 there out of the 6. So this is even. And then we want to know or a number less than 3. Well, it doesn't say less than or equal to, it just says less than 3. So you have 2 options there. That's why I wrote 2. So this is your evens. And then now we're going to take away the time that it could be both. So in this case, 2 is even and is also less than 3. So there's one option. So that means that it would be both. So we're subtracting 1 and then we keep our totals there. So go ahead, 3 plus 2 is 5, minus 1 is 4 over 6, and then that's going to simplify to 2/3, and that's your answer. All right, and then here, an automobile dealer decides to select a month for its annual sale. Find the probability if it will be either September or October. Well, it's either September or October. It can't be both. So this is exclusive. And we're going to find the probability of September, which is 1 month out of 12. So there are 12 months in a year. Oops. So make sure you know that. So there's 1 September in the year, and you're going to add that to 1 October. And then since they don't have any overlapping, you just add them together. You get 2/12, and that simplifies to 1 over 6, and that's your answer. All right, so what you're going to do is you're going to complete these and make sure you list out your options and then try to figure out, is it exclusive, is it inclusive? And then from there, use the little formulas at the top. So you can do here or you can do here. And then that is how you add probability.